Hi, you guys. So we are starting kind of a new topic on probability. So this is lesson 10, probability of simple events. Go ahead and pull out your pen and paper. As always, we have the slides numbered at the bottom. So the first part we're going to do is some vocab. Just in general, probability is number between 0, or we can think of that as 1% or 0%, and 1 or 100% that tells us how likely an event is to occur. A sample space is a set of all possible outcomes, while an event is a set of all desired outcomes. Oh. Theoretical versus experimental probability. So theoretical is what should happen, experimental what is actually happens. So theoretical probability is number of events over number of sample space. Experimental probability is number of times the event occurred. Experimental probability is the number of trials. So this will make more sense as we work through these, but you want to go ahead and copy these down before you move on to the next slide. Okay, so when we have a cube with 1 through 6 on this, kind of think of this like a dice. The number rolled will be recorded as the outcome. Give the sample space, then you give the outcome of an event of rolling a number greater than 5. If there's more than one element in a set, separate them with the comma. So a set is considered like everything that we'd have. So when we roll the dice, we can get a 1. It has to separate with a comma. Or when we roll the cube, we can get a 1. 2, 3, 4, 5, and 6. An event is what things that we can get that would be greater than 5. So that is only the 6. So this answer would just be 6. I want you guys to pause the screen on your own. Try to list all the events of rolling an odd number. Pause the screen and do that. Okay, so if you guys did that, you'd have gotten 1, 3, and 5 are our odd numbers. Okay, go ahead and continue on to the next slide. Oops. So this has a bag with 10 tiles that has 10 letters in it. We're going to pick one tile out. What is the probability of picking a vowel? So this is theoretical because we don't have data. We haven't actually done it. So it's going to be probability of a vowel. This P means probability of a vowel. Remember, I do if you go back to the first page, or slide 2, which all are vocab, theoretical probability is number of events over number of sample space. So go ahead and think about, what is my sample space? So if we want to write that over here, we can. My sample space, there's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's going to be 10 of those. And my event of a vowel, of those 10, we're seeing how many vowels we have. we have E, I, seeing if we have any others. So the event of eval is 2. So 2 out of the 10 tiles that I could pull out would be eval. So my probability is 1/5. Or you could write that as 20% or 0.2. Oh, it says right, your answer is a fraction. So that's our fraction in simplest form. Okay, go ahead and pause your screen to this next one. The probability of picking a non-val. So pause your screen and go ahead and do that. So I still have 10 total tiles. 8 of them are non-val, so I get 5/4. So the state lottery board is examining the machine that randomly picks the lottery numbers. On each trial, the machine outputs a ball with 0 through 9 on it. The ball is input in the machine. It's tested 1,000 times, and this is the data it gets out. So question A, assuming it is a fair machine, compute the theoretical probability of getting a 3. So what's important there to see is that it wants the theoretical probability. So we do this, the probability of getting a 3. How many possible outcomes over like ways to get 3? There's 10 outcomes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then ways to get a 3, there's only one of them. So it'd be 1/10 or 0.1. Oh, it says round your answer to the nearest thousands. So this is tenths, hundredths, thousandths. Now it wants us to do the experimental probability. So now we need to think of total trials, number of times a 3 occurred. So it tells us it did 1,000 trials and a 3 occurred 90 times. And that is simplifying to that. The last one we're going to do together is assuming that a machine is fair, choose the statement below that is true. The larger the number trial, the greater the likelihood that the experimental and probability will be closer. The experimental will never be close to probability or theoretical. Smaller the experimental, smaller number of trials means the closer the two probabilities will be. So if we think about this, the more and more you do something, the more and more data you have, and it's not going to be as extreme. So our answer would be the larger the number of trials, the greater likelihood that, oh, that looks bad. The larger the number of trials, the greater likelihood that the experimental is close to theoretical. I'm going to go ahead and pause the screen and do these bottom 2 problems on your own. Okay, this is what we should have gotten for these. They actually ended up being the same, which is really cool. So in an aquarium, there's 6 large fish, 8 small fish. Half of the small fish are red. If this fish is selected, find the probability that's a small red fish. It wants it in fraction form. So probability of small red, not read red, is going to be total fish over the number of small red. So if we look at the total fish, we have 6 and 8. So we have 14 fish total. Small red half of the red fish, the small fish are red. So we have 8 small divided by 2. So we have 4 small red, which gets us 2/7. It asks us for fraction form, so we're good there. Okay, another way that we will see probability a lot is with cards potentially. There's 52 cards in the deck. This gives us a table with the 4 suits, the type of card that each suit has, and it highlights face cards. So it says, what is the probability that a card drawn is a 6? So we want, it wants a fraction, so probability of a 6. This is going to be out of 52. So there are 1, 2, 3, 4 6s, which is going to get us 1 out of 13. This wants to know probability of a diamond. So we can count how many diamonds there are. There's 1, 2, 3, 4, 5, 6, 13. A fourth of the cards are diamonds. And this says, what is the probability that a card is a 6 and a diamond? It actually naturally made it green. That makes me so happy. So we see there's only one of those. So out of 52, there's one of them. So a point is selected at random. In the square below, find the probability that the point is in the circular region. Each side of the square is 8. The radius of the circle is 4. So I want to know out of this whole square what percentage, or what probability of it is the shaded circle. So probability of point on shade part is going to equal area of square is going to be our total part, but we only want the area of circle. So my area of the square is going to be 8 times 8. My area of a circle, remember this is pi r squared. And they told us for pi to use 3.14. R is 8 squared. And it wants the nearest hundredth, which means 2 decimal points. So that's 2 decimal points.